Hi, thanks for joining me. I'm Christian here at Algebraix Data. I'm going to be showing you a small demonstration of how Algebraix Query Accelerator seamlessly integrates with Apache Spark to reduce Spark SQL query time without the need for any manual tuning. To demonstrate this, I'm going to show you the performance difference between running 10 queries over 10 gigabytes of data in a generic installation of Spark versus rerunning that same set of queries with Algebraix Query Accelerator enabled on that same cluster. So first, let's jump into our sample PySpark application so you can see what these demo queries look like. This is a sample query from the TPCH benchmark framework that performs a six-way join of sample sales data. The data set we'll be using is 10 gigabytes in size. The cluster is a 3-node cluster of M4 2x large nodes on the Elastic MapReduce platform on Amazon Web Services. After each query, I'll be running that query again and changing the region that the data is selecting, so the query has to focus on a different portion of the data set. We'll do this with variations a total of 10 times. To capture our baseline data, I've simply run this set of queries on Spark without the accelerator enabled. The results of that run look like the following chart. Notice that there's a slight variation in performance with each subsequent run. Even when Spark is given the chance to repeat itself, there's never a significant speed up. In order to make these speed up, you'd have to learn and implement Spark's version of caching and persistence. Our goal is to give you the best performance optimizations possible without you having to change your application or your queries. Now let's rerun our benchmark with Aqua enabled. To enable Aqua, we modify our application to import Aqua Spark, and then we create a new Aqua Spark context. Once you've made that minor change, that's all you've got to do. The rest of the Spark APIs are the same. We purposely designed it that way so users could maintain a consistent user experience between the two applications. Okay, let's begin. All right, now that we've run our test, let's look at the baseline data and the new performance numbers side by side. The baseline data moves around a few seconds with each run, but isn't a matter of performance improvement, but rather it's just a performance inconsistency. When we run that same application with Aqua enabled, we observe roughly the same time on the first query, and then on the second query, there's a bit of an increase, which corresponds with the time that we take to produce a reusable computation. And then from query 3 through 10, the performance floor drops off and we see a massive speed up, with each query taking around 1 second. If you compare the total time before and after implementing Aqua, you'll see a significant change. The baseline benchmark ran a total of 296 seconds. The same benchmark with Aqua enabled ran for 142 seconds. That's a difference of 154 seconds, which is roughly 2.5 minutes. So, what does this mean for you? If you're running large complex jobs in production, then it's possible that the improvements could be very impactful to your business in several ways. Large, several hour long jobs could become significantly shorter. Large, expensive clusters could be shut off sooner. The cluster size itself could be reduced, and the node types that make up the cluster could be swapped out for less expensive node types. These are all benefits that we aim to deliver to Spark users. To learn more about Algebraix Query Accelerator, visit algebraixdata.com. Thanks for watching.